Welcome to Brain Vision.
In this example, first we want to calculate the volume of a sample of 11 grams of chlorine gas at a temperature of 82 degrees Celsius and a pressure of 5.6 times 10 to the 5th pascals. And then in the second part of the problem, we're going to allow some of this gas to leak out of the tank it's being held in. And what we're going to try to figure out is how many grams leak out based on what the new temperature and pressure are. So for part one, let's just focus on the volume. So this is an ideal gas. So we'll want to apply the ideal gas law here, which is PV equals nRT. And we want to solve for volume. So we will divide both sides of that equation by P. And we'll end up with nRT over P. Okay. So we have the temperature and we have the pressure, but we don't have the number of moles here. We have the total mass, M. But lucky for us, we can readily convert between molar mass, or the total mass, and the number of moles, as long as we can know or look up the molar mass. So if you recall, that relationship is just M is equal to little n times M. So the total mass is just equal to the molar mass times the number of moles. So if we were to rearrange this for little n, we would have n equals little m over big M, where for us this is going to be for chlorine gas. So we can substitute that into our ideal gas law here, and we'll have V equals little m over big M, chlorine gas, times RT over P. So now all we have to do is just plug in our numbers here. Since the molar mass and the mass are both in grams, those will cancel each other out. We don't have to worry about converting. But we will want to convert our temperature here from Celsius to Kelvin. So if our temperature is 82 degrees Celsius, we add 273.15 to that to get the Kelvin amount, which is 355.15 Kelvin. So now if we were to plug in all our values here into our equation, we would get that the volume of our gas is 8.18 times 10 to the minus 4th meters cubed. So there's part one. All right, for part two, now we're allowing gas to leak out of our tank here. So this is part two. And we have a new pressure and a new temperature. So the final temperature is 31 degrees Celsius. And the final pressure is 3.8 times 10 to the 5th pascals. Okay. So right off the bat, I'll just convert our temperature here to Kelvin, so we don't have to worry about it later. So again, just add 273.15, and we'll have 304.15 Kelvin. Okay. So let's go ahead and write out the ideal gas law for this second state here. So PV equals nRT, except now we have a new pressure, we have a new temperature, we have a new number of moles, but the volume is actually the same, or the volume of gas that's left in our tank, right? Because our tank doesn't change shape at all. So the volume, we can say, actually doesn't change. So now, let's just solve this equation here for the number of moles, since we want to know how much is left in our tank. So we'll divide both sides by RT. And we'll just have N final is equal to P final times V over R times T final. So we have V, we have P final, we have T final, and we have R. So we can calculate the final number of moles. And if we do that, our final number of moles will be 0.123 moles left in the tank. So we want to determine how much gas leaked out in terms of a mass, so in grams. So what we're going to want to do here is first convert this amount to grams, and then subtract it from our original mass up here, 11 grams, in order to figure out how many grams leaked out of the tank. So to go between moles and mass, again, we just use the mass is equal to the number of moles times the molar mass, where the molar mass we'll be using, again, is that of chlorine gas up here, which is 70.9 grams per mole. So if we do that, we'll get that there are 8.72 grams of our gas remaining in our tank. So the change in mass, or how much leaked out, is going to be the original amount, 11 grams, minus how much is left. And that'll come out to be 2.28 grams. So we just determined that 2.28 grams of our chlorine gas leaked out of our tank.